Dear students, today we will learn a new chapter in trigonometry unit. The new chapter name is Inverse Trigonometric Functions. In the previous class, we learned transformations, and here we learn inverse trigonometric functions, objectives. On completion of this period, you would be able to know the concept of inverse of a function, know the concept of an inverse trigonometric function, define sin inverse x, cos inverse x, tan inverse x, cosec inverse x, sec inverse x, and cot inverse x. State the properties of the above inverse trigonometric functions. Do you know the meaning of an inverse function and when it exists? Suppose we have a function y equals to f of x, then inverse of the function f of x denoted as f inverse and defined on y, and f inverse of y equals to x. Suppose a function f a to b and f is a bijective, then its inverse f inverse exists and f inverse is b to a exists. Example, suppose f of x equals to root x, then f of 9 equals to 3, f of 3 equals to 9, and f inverse of a equals to a square. Another example, suppose f of x equals to log x, then f of e square equals to 2, f inverse of 2 equals to e power 2. Existence of trigonometric functions. Since inverse exists only for a bijective function, all trigonometric functions are periodic, they are non-bijective. For example, sin 60 equals to sin 120, but pi by 3 not equals to 2 pi by 3. Here the sine function is non-bijective. The inverse for sine function does not exist. But if we restrict the domain of sine function between minus pi by 2 to pi by 2 and the range in minus 1 to 1, the sine function is bijective. Similarly, the tan function is also not bijective, but if we restrict domain of tan function in minus pi by 2 to pi by 2 and range between minus infinity to plus infinity, it is bijective. Hence, inverse for the tan function exists in the domain minus infinity to plus infinity with the range minus pi by 2 to pi by 2. Now we define the inverse trigonometric functions as follows. Hence, inverse for the sine function exists in the domain minus 1 to 1 with the range minus pi by 2 to pi by 2. Similarly, if we restrict the domain of cos function between 0 to pi and range between minus 1 to 1, the cos function is bijective. Hence, inverse of the cosine function exists in the domain minus 1 to 1 with the range of 0 to pi. Inverse sine function, sine inverse, or we can say arc sine. Suppose x equals to sine y, then we can say that y equals to sine inverse of x for x belongs to minus 1 to 1 and y belongs to minus pi by 2 to pi by 2. Hence, sine inverse x is an angle whose sine value is x. The graph of sine inverse x is shown in the picture. So, if you take some values, you will get this type of graph. If you have sine 90 means 1, like this, you can apply the values. And similarly, inverse cos function, cos inverse or arc cos. Suppose x equals to cos y, then we can say that y equals to cos inverse of x, where x belongs to -1 to 1 and y belongs to 0 to pi. Hence cos inverse x is an angle whose cos value is x. The graph of cos inverse x is shown in the figure. Inverse tan function or tan inverse, or we can say arc tan. Suppose x equals to tan y, then we can say that y equals to tan inverse x for x in minus infinity to infinity, and y in minus pi by 2 to pi by 2. Y in minus pi by 2 to pi by 2. Hence, tan inverse x is an angle whose tan value is x. The graph of tan inverse x is shown in the figure. Similarly, cosec inverse x is a function defined in minus infinity to minus 1 union 1 to infinity as an angle between minus pi by 2 to 0 union 0 to pi by 2, whose cosec value is x. Sec inverse x is a function defined in minus infinity to minus 1 union 1 to infinity as an angle between 0 to pi by 2 union pi by 2 to pi. See, the brackets are very important. If you are mentioned square bracket, means that value should be considered, and if you place your open bracket, means below that value will be considered, not the end value. So cot inverse x is a function defined in minus infinity to plus infinity as an angle between 0 to pi whose cot value is x. So don't worry about the domain or range or values. If you are getting confusion, don't worry. These are values which are defined in that particular values. So by simply, if you enter the value, you can get desired value, means it is exist. If it is not getting value, means you are that is not in the domain or range. So properties of inverse trigonometric function. Sin inverse x we can write cosec inverse 1 by x, or cosec inverse x equals to sin inverse of 1 by x. And similarly, cos inverse x equals to sec inverse of 1 by x. And sec inverse x equals to cos inverse of 1 by x. Tan inverse x equals to cot inverse of 1 by x, or cot inverse x equals to tan inverse of 1 by x. Let us see the proof. Sin inverse x equals to a, sin a equals to x, then cosec a equals to 1 by x. That implies a equals to cosec inverse of 1 by x. Sin inverse x equals to cosec inverse of 1 by x. Equation 1. In the above, replace x by 1 by x, we get inverse of 1 by x equals to cos 1 by 1 by x, that is cosec inverse x. Sorry, not cos, cosec. From 1 and 2, proof of 1 follows. The proof of 2 and 3 are also similar as above. So property, some of properties here given. Sin of sin inverse x equals to x, that equals to sin inverse of sin x. Similarly, cos, tan, cot, sec, cosec. Here is the proof. Let sin inverse of sin of x equals to a, then sin x equals to sin a. Sin get cancelled, x equals to a. That implies x equals to sin inverse of sin x. Consider as a 1. Similarly, let sin of sin inverse x equals to beta. So here that is not a, that in the above it is alpha. So here it is beta. So sin inverse x equals to sin inverse beta. Inverse get cancel, x equals to beta, and x we can write sine inverse of x. From 1 and 2, proof of 1 follows. The proof of 2 to 6 are also similar as above. Sine inverse minus x equals to minus sine inverse x, and cos inverse of minus x equals to pi minus cos inverse of x. Tan inverse of minus x equals to minus tan inverse x. Cot inverse of minus x equals to minus cot inverse x. Sec inverse of minus x equals to pi minus sec inverse of x. Cosec inverse of minus x equals to minus cosec inverse of x. Here observe cos and sec. The two are different, remaining are all having negative in front of their functions. See the proof. Let sine inverse of minus x equals to a, then minus x equals to sine a, minus sine a equal to x. That implies, here take in place of a alpha. So sine of minus alpha equals to x. Minus alpha equals to sine inverse of x implies alpha equals to minus sine inverse of x. Sine inverse of minus x equals to minus sine inverse x. Let cos inverse of minus x equals to alpha, then minus x equals to cos alpha. X equals to minus cos alpha implies x equals to cos of 180 minus alpha. And cos inverse x equals to pi minus alpha. That implies alpha equals to pi minus cos inverse of x. Cos inverse of minus x equals to pi minus cos inverse x. The proof of 3 to 6 are also similar as above. Some more properties. Sin inverse x plus cos inverse x equals to pi by 2. Tan inverse x plus cot inverse x equals to pi by 2. Cosec inverse x plus sec inverse x equals to pi by 2. So I have fever, so that my voice is a little bit low. So please see the PPT. And wherever the most important, I will give you more explanation, so don't worry. See the proof. Let sine inverse of x equals to a, then x equals to sine a. In examination there are no questions like proofs. This is for your understanding purpose I am giving. X equals, and these proofs are available in textbook also. X equals to cos pi by 2 minus alpha, that equals to cos inverse x to pi by 2 minus alpha, and cos inverse x plus alpha equals to pi by 2, then cos inverse x plus sin inverse x equals to pi by 2. The proof of the second and third are also similar as above. Property 5. Tan inverse x plus tan inverse y equals to tan inverse of x plus y by 1 minus xy. Tan inverse of x minus tan inverse y equals to tan inverse of x minus y by 1 plus xy. Cot inverse x plus cot inverse y equals to cot inverse of xy minus 1 by x plus y. Cot inverse x minus cot inverse y equals to cot inverse of xy plus 1 by y minus x. Proof. Let tan inverse x equals to a and tan inverse y equals to b. X equals to tan a and y equals to tan b. Now tan of a plus b equals to tan a plus tan b by 1 minus tan a tan b. In place of tan a put x, and in place of tan b y, then we get a plus b equals to tan inverse of x plus y by 1 minus xy. So after substitution we will get the required proof. The proof of second to 4 are also similar as above. Example problem C. Show that sin inverse x equals to cos inverse of under root 1 minus x square. Let sin inverse x equals to a, then x equals to sin a, cos a equals to under root of 1 minus x square. According to the triangle, a equals to cos inverse of 1 minus x square, then sin inverse x equals to cos inverse of under root 1 minus x square. Example 2. Show that sin inverse of 8 by 17 equals to cos inverse of 15 by 8. Let sin inverse of 8 by 17 equals to a, then 8 by 17 equals to sin a. From triangle, that is right angle triangle cos a, we can write 15 by 8, then a equals to cot inverse of 15 by 8. Sin inverse of 8 by 17 equals to cot inverse of 15 by 8. Example 3. Show that 2 into sin inverse x equals to sin inverse of 2x into under root 1 minus x square. Here 2 into sin inverse x equals to a, then sin inverse x equals to a by 2, sin a by 2 equals to x, cos a by 2 equals to under root of 1 minus x square, sin a equals to 2 sin a by 2 cos a by 2, then sin a equals to 2 into x into under 1 minus x square, then a equals sin inverse of 2x into under root of 1 minus x square. This is how we proved. And next example, find the value of cos of tan inverse of 8 by 15. So this is the solution. Tan inverse of 8 by 15 equals to a, then tan a equals to 8 by 15. Cos a we can write 15 by 17, then a equals to cos inverse of 15 by 17. So then take cos on both sides, then we will get 15 by 17. So all are based on right angle triangle. We can easily get the proof. Prove that sin inverse of 3 by 5 equals to cos inverse of 4 by 5 equals to tan inverse of 3 by 4. Let sin inverse of 3 by 5 equals to a, then we get sin a, from that we get cos a, and from that we get tan a. Finally we can write as a proof. So in this class you learned the concept of inverse function and inverse trigonometric function, the definition of 6 inverse trigonometric functions, the existence of inverse trigonometric function in the domains and range, solve problems. See the quiz. So these are the based on thinking the value of sin inverse 2. So answer is does not exist. Tan of cot inverse x equals to, answer is 1 by x. Tan inverse x plus tan inverse 1 by x equals to pi by 2. So fourth one answer is B. So these are the assignments. Try to do. If you have any doubts, ask me, and open PPT in one device and see the video in another device, because sometimes screen clarity may miss. And any doubt you can ask me. Don't worry about domain or range, that will understand step by step. And the problems are very simple and easy. One thing, you know the properties, so write each property 10 times. Have a nice day. Thank you.